Alright, you guys. I hope this works. This is my second time at this. So, this is some calculator work, and I don't have a calculator. But you guys have done a lot of this stuff this year, so I'm going to describe, show you what you should go through. If you don't have a calculator, I'll get it out now. You can pause until then, and we'll get started. If you look up here, it says I can write, graph, analyze, and model by performing a logarithmic regression. So that's the type of regression that's in your calculator. We've done linear, we've done a lot of regressions. And again, it's just when you have data and you get an equation. So, a biologist studied a population of foxes in a forest over a period of time. The table gives the biologist the information the biologist collected. From the data, the biologist obtained the exponential mode p equals 62 times 1.12 to the t power, where p is the population and t is the time in years. He wants to have a model that gives time it takes for the fox population to reach a certain level. So here's what right now, he's got a model that says your input is years and your output is foxes. He wants a model with the fox as the input, right? And it gives the time it takes the fox population to reach a certain level. So he wants to switch this. He wants to find the inverse. And we know the inverse of an exponential is logarithmic. So we're going to do it. So here's what I want you to do. I want you to do stat edit, and you're going to type in some new data. I wrote the table here, but really all it is we're switching these. We're making this the first column, and that's the second column. So do that. Stat edit, and type these columns in reverse order. And pause until you're done, and I'll wait like 5 seconds and keep going. Okay, now you should have it typed in. This is a skill you're going to need, so have it typed in. Alright, once this data is typed in, if it's correct, I mean, they've got to match up, the number of rows has to match up, you should be able to get a logarithmic, or it's actually a natural log regression. Alright, so you're going to hit stat calculate, and when you hit calculate, go down to like 9. It said natural log regression. And if you hit enter, you should get this data. Alright, first it tells you it's a natural log regression, then it tells you how to make the formula, a, b times ln x. Then it'll tell you what A and B are. A is negative 35.6-ish. It's longer than that. I kind of rounded. And B is about 8.6586. A little longer than that, but I rounded. Alright. These R squared and R values just tell you that if it's close to 1, then honestly, you've got a pretty good model. And this is almost perfect for a natural log regression. I mean, it's almost at 1. It's 1/100th away. Alright. So, if we plug A here into this and B into this, you get this equation, right? There's my A, negative 35.6 plus my B, 8.66, the natural log of P. So we're putting in population and we're getting out time. Alright. If, for instance, if you plug this into your calculator and typed in 18, you'd get about 475 out. So what this should be is the inverse of P equals 62 well, the original equation they gave us up here, right? Times 1 and 1 and 12/100ths to the t power. And I'd like you to graph them both. So you can either type this in by hand or have the computer put it in for you if you remember how to do it. And you can type this by hand. And if you graph it, this I'm just guessing, but it should look something like this. They should cross, right, and you got that y equals x right there. I believe you'll see something that looks like this if you have the right windows. Probably a good idea, since we're reversing this data, is to make sure both x and y start at 0 and end at like 500. And you should see something that looks like this. Alright, and what do we notice? Well, they're reflections over y equals x, which makes them, right, that makes them a inverse function. So I'm going to stop with this. I'm not even going to give you page 4, right? We'll do page 4 together tomorrow, and that's it for tonight. I'll see you.